down as a reminder, you can. Otherwise, if you want to just glance it over to refresh your memory, you can do that as well. So we're looking at the parent function, x squared. If you're shifting it vertically, either up or down, you add or subtract a value to the end of the function. So g of x equals f of x plus k or minus k. For a horizontal shift, again, remember the asylum. So we're either subtracting h if we're shifting right or adding h if we're shifting left. Reflections across the y-axis, you make the x value the opposite. Think about the fact that x equals 2 is reflected across the y-axis from x equals negative 2. Reflecting across the x-axis, you make the entire function negative. For vertical stretches and compressions, we have multiplying outside the asylum. So if a is greater than 1, it's a vertical stretch. If a is between 0 and 1, it's a vertical compression. And finally, the horizontal stretches and compressions, again, remembering the asylum. If the b value is between 0 and 1, it's actually a stretch. And if the b value is greater than 1, it's actually a compression. Okay, so we're going to do a quick review of the graphs that we looked at yesterday or today in class. The first is a translation. So again, noticing that we have x minus 1 in parentheses squared, that really means our vertex is positive 1. And outside the parentheses, we have negative 3, which means the y-coordinate of our vertex is negative 3. It's outside the asylum, so it acts normal. So here's our vertex. Again, we use those ordered pairs from the parent function. But this time, instead of graphing ordered pairs, we're graphing direction. So instead of graphing the ordered pair negative 2, 4, we take our new vertex, which is 1, negative 3, and we shift 2 units to the left and 4 units up to find our new ordered pair. For negative 1, 1, we shift 1 unit left from our vertex and 1 unit up to get our new ordered pair. 1, 1 would mean from our vertex right 1, up 1, and 2, 4 from our vertex right 2, up 4. Make sure when you're graphing a parabola that you have a curve and not a point. The point would represent an absolute value function. The parabola curves like a U shape. Okay, so the next one we're going to look at is a scale change. This one is a vertical scale change because the scale factor is not grouped in the asylum with the x. So what we do is take our parent function ordered pairs, and we multiply the y values by our scale change. Because the negative is on the outside, we're making the entire function opposite. It reflects across the x-axis. So again, our x-coordinates, or our x values, stay the same, and our y values are multiplied by negative 5 halves. And then we plot our new ordered pairs. And I can't fit negative 2, negative 10, or 2, oops, I lost my negative signs on those, 2, negative 10 on the graph. So I'm going to graph the ordered pairs that I have. This time we're looking at a horizontal scale change. It looks like we're compressing, but really we're stretching by a factor of 4. So when you're doing horizontal scale changes, you multiply your x value by the reciprocal of what's in the parentheses. So our y values stay the same this time, and our x values are multiplied by 4, the reciprocal of 1/4. Right, and again, I don't have room for my negative 8/4, so I'm going to plot negative 4, 1, 0, 0, 4, 1, and attempt to make a curve instead of a point. All right, so this is the new material. We're going to be writing equations for transformations. So the first thing that I want to take a look at is reflecting across the x-axis. So remember, think about if we have this point and we want to reflect it across the x-axis, the y value becomes opposite. The x value stays the same, the y value changes. So we're going to make the entire function negative. The next piece is a horizontal translation, so that goes inside the asylum with the x. Shifting left means it will look positive. And then a vertical translation down 6 is normal, so that'll be negative. So now we're going to graph this function. This is a shift, so I like to just think about the parent function in my head. If you need to write down those ordered pairs, you can do that. But our new vertex is left 5, down 6. So I'm going to plot that ordered pair first. And then thinking about the fact that this is reflected across the x-axis, so instead of opening up, it will open down. Anytime your quadratic function has a negative sign outside the parentheses, it opens down. So instead of going left 2, up 4, I'm going to go left 2, down 4 from the new vertex. Instead of left 1, up 1, I will go left 1, down 1. And same to the right, right 1, down 1, and right 2, down 4. Okay, so the last example we're going to take a look at is another writing the equation for the transformation and then graphing. So our horizontal translation this time is right 3, so inside the asylum that looks negative. Vertical translation up 2, so outside the asylum that's normal. A vertical stretch by 5, vertical stretch is outside the asylum, so that's normal as well. And this time we're reflecting across the y-axis, which makes what's inside the parentheses the opposite. So my x becomes negative and my 3 becomes positive. So thinking about instead of shifting right 3 like it tells us to, so let's say we're over here, we're reflecting that across the y-axis, so it comes back over here. So it's really a shift of left 3, which is why that 3 becomes positive. Okay, so let's take a look at graphing this. Again, find your vertex. So looking at the fact that the 3 is positive inside the asylum, so it's really a negative 3. And outside the asylum, we've got a plus 2, so that's up 2. So I'm going to plot my vertex. And this time I have to think about those ordered pairs because I'm stretching it. So I'm going to go ahead and write down the parent function ordered pairs and stretch those values. So it's outside the asylum, so it's affecting our y's. And again, this is going to be direction because we've changed the vertex of our quadratic function. Since the vertex is no longer 0, 0, these new ordered pairs that we're going to write right now are changing the direction where from the vertex, from our new vertex, as opposed to them actually being the ordered pairs that we're plotting. So I'm going to multiply all of my y values by 5. So obviously I only have room for my left 1 up 5. I don't have room for my left 2 up 20. So from my new vertex, I'm going to shift left 1 up 5. And also right 1 up 5. Okay, so that is the lesson for tomorrow. You'll get the assignment in class.